right, example 3. Find the volume of the solid obtained by rotating the region bounded by y equals 2x squared minus x cubed and y equals 0 about the line when x equals 2. I've already chosen a scale of 1 for x and 0.4 for y. Again, if you were to get yourself an XY chart, you can kind of get a gauge how big things need to be to make things happen. But x equals 2 is the line that we're rotating about. And I'm still getting a couple of you graphing these in the wrong direction. So x equals 2 is a vertical line. Just keep in mind that whenever x equals a number or y equals a number, they're setting that number in stone. So x equals 2, 1, 2, x has to be there. Y is free to be what it wants to be, so it can move up and down. So that creates that vertical line. Where it says y equals a number, it's going to say y has to be a certain number, then we're free to move left and right. So you create the vertical line for x equals number. So our axis of rotation is vertical. When the axis of rotation is vertical, we know we're going to do a dx integral. So again, if you just go ahead and start off with that thinking, if you know which type of integral you want to get, that helps you to establish the radius and height of the cylinder we're going to use. All right. I'm going to substitute numbers in there. Y equals 0 is the bottom of the region. Y equals 0 is here. I'm on the assumption that we're going to not cross the axis. They usually don't make the axis. They're not going to have like some shape like this and then put the axis somewhere in there. All right, they don't do that. That would be ridiculous. So go ahead and make some assumptions when you do these that the graph's going to be in a pretty reasonable place. Maybe it goes a little bit further that way. That's fine. But we should expect it to not go beyond the axis. And if I tried it out, if I put 0 in, 0 minus 0 makes 0, so 0, 0 is a point on this, right? If I put 2 in, 2 times 4 is 8, minus 2 cubed, 8 makes 0 also, so 2 comma 0 is a point. So I can see that those are my boundaries where y equals 0 for this equation. All right, if I picked x equals 1, 2 minus 1 is 1, so we're going up by 0.4, there's 0.4, 0.8, 1 is right there. All right. Now, that's all the actual values of x where I have a place on the x-axis, right? But if I could pick 0.5, and that might be where I have to start getting my calculator out. I don't want to close that earlier, but let's see. 0.5 squared is 0.25 times 2 is 0.5, 0.5 cubed is 0.125, 0.375. You got that? Make sure. 2x squared minus 2x squared minus x cubed. Perfect. All right, so if I go 0.5, we're at 0.375, and 1.5, we're at 1.125. So 0.5, 0.375, which is almost 0.4, right? And then 1.5, 1.125, and again this was 1, so 1.125 is a little bit higher than that, right? Maybe about there. So it kind of looks like it's going up, and it has to hit this point here, so it's going to shoot down pretty quickly. So my thought is it's going to kind of come up like this and then go down. The graph is not required to be perfect. It has to be good enough that you can understand where the graph is going to be, where it's going to be happening. So that kind of gives me a visual of what's going on here with this graph. And if I just shade in, we always want to shade in our original region because that helps me establish the interval. Region starts at x equals 0, ends at x equals 2. That's going to be, for dx, that's going to be the interval of my integral. A lot of I words there, interval and integral. It's hard to say. So, x equals 0 start, x equals 2 end. All right. If I rotate that around the x-axis, we're going to end up getting a mirror image over here, like so. So there's what my shape's going to end up looking like, something along that line. All right. Now, if I draw a cylinder to represent, again, a hollow cylinder represent what's creating this region, I would put a circular base around the axis that we're rotating. Okay, so there's the base of the cylinder. The height is here, and there's the other base. All right. So the radius of this cylinder goes right here, and the height of the cylinder goes right here. And we can see very clearly the height is y, right? No concerns with that. Height equals y. Okay? We're doing a dx integral though, so I'm going to have to say height equals y, and the y that we're getting is this graph here, and that graph is created by that right there, so our height's going to be 2x squared minus x cubed. A little check mark next to that's the height we want to use, right, in terms of x. The radius does not equal x. All right, so again, what you have to do is, here's my original region, the shaded in one. I always want to draw my radius from the axis into that region, into the shaded region. There's the radius always, so it's always from here to this edge, from here to this edge, and so on, right? So, this right here is always x. So from here to here is always x, from here to here is always r, and from here to here is always what?
2.
2, very good. From the axis of the y-axis to the axis of rotation, which is x equals 2, that distance is always 2. So I can see very clearly that r plus x has to equal 2, which means r is going to equal 2 minus x. There's my radius in terms of x. I got my height in terms of x. I've got my x interval. So now I can create my integral. Volume is going to equal 2 pi times the integral from 0 to 2 of height, which is 2x squared minus x cubed, times radius, which is 2 minus x dx. Miscalculated the space I was going to take. Make it prettier here. So, so 2 minus x dx. All right. Now, in its current form, that would not be very nice to integrate, right? It's a product of things. So if I did a little FOIL, first times first, outer, outer, inner, inner, last, last, I'm going to get 2 pi integral from 0 to 2 of 4x squared minus 2x cubed minus 2x cubed plus x to the fourth. And of course that's going to be minus 4x cubed right there, right? So 4x squared minus 4x cubed plus x to the fourth is the integral. So now if I integrate that, I'm going to get 4x cubed over 3 minus 4x to the fourth over 4, which is minus x to the fourth, plus x to the fifth over 5.
Bless you. Bless you.
Going from 0 to 2. I can put 2 in, get some numbers. If I put 0 in, I'm going to get a bunch of zeros, right? So I just really have to substitute the 2 into this to evaluate. Again, substituting 0 just gets a bunch of zeros, so I can just ignore that. So volume is going to equal 2 pi times. If I put 2 in, I'm going to get 8 times 4 is 32 over 3. 2 to the fourth is 16. 2 to the fifth is 32 over 5. Common denominator there is 15, so if you do that, 2 pi, 15 on the bottom, times 5 times 5, times 15 times 15, times 3 times 3. 160 and 96 make 256, minus 240 makes 16. So I get 2 pi times 16/15. So the answer is 32 pi over 15. Units cubed.